The purpose of the beverage density lab is to determine sweetness in the beverage. For example, the first thing you need to determine is if you think about when you've had orange juice to drink, Sprite, and Gatorade, which one is the sweetest and which one do you think is the least sweet? So whichever one you think is the sweetest, you can put a 1 next to. And then whichever one you think is in the middle, you can put a 2. And then the least sweet, you can put a 3. But this is your prediction. So this ranking is based on your personal experience. So we're going to test our hypothesis against some calculated values in the lab. And we want to see if we can figure out, using density, if we can find out the percent sugar that is in each of these beverages and compare that to what we know from personal experience. In this lab, we're going to use a correlation curve to help us do that. You will not be tested on the correlation curve, but we want to give you some experience on how to use it so that if you see it in the future, you know what it means. And lastly, in this lab, we're going to try to figure out the difference between accuracy versus precision. And we're going to use your data and we're going to look at it with the class's data to see how accurate you were and how precise the entire class was. So this is the big picture of the lab. We're going to practice using density. We're going to see what a correlation curve is all about, and we're going to see if we can determine the difference between accuracy and precision. So one thing to know about accuracy versus precision: accuracy is how close you are to the correct value. How close you are to the correct value. So if you look at the above picture, the golfer, to be accurate, he needs to get the golf ball into the hole. You can see he's pretty close, so the accuracy is pretty good because he's very close to the hole. Precision is if you do something multiple times, how close are your measurements to each other? So how close are repeated trials to each other? So in the first picture, good accuracy because the golfer is close to the hole, and it's also good precision because every time he took a practice shot, it was in roughly like the same proximity to the hole. In the second picture, the accuracy is poor because he's not that close to the hole, but the precision is good because every time he hits the ball, he's getting it in about the same location. In the last picture, it's poor accuracy because none of his practice shots are near the hole, and it's poor precision because every time he takes a shot, it's in a different location. So accuracy, how close you are to the correct value, and precision, how close are repeated trials to each other. We'll look at both of those numbers in this lab, and to look at your own data, how accurate are you and how precise are you compared to the classmates. In this lab, what you're going to need to do is to determine density of the 3 liquids. We're going to find the density of 10 milliliters of orange juice, Gatorade, and Sprite. To do this, you're going to take a graduated cylinder and you're going to put it on a balance, and when you use the balance, you're going to press 0 or the tar button to make sure that we're not recording the mass of the graduated cylinder. Once the graduated cylinder is on the balance and the balance reads 0 grams, you will use a pipette and you will add with the pipette 10 milliliters of orange juice. Once you see 10 milliliters in the graduated cylinder, remember you're going to read 10 milliliters at the bottom of the meniscus. You will look at the grams and record the value that you got. You know you'll be in the right ballpark if you get somewhere around maybe 10 grams, and you'll include the significant digits, so you will probably get 10.12 grams or 10.3. But we're using a pipette to make sure that your data is going to be as accurate as possible. So the first step in your data table, you're going to record what is the mass of 10 grams of orange juice, what is the mass of 10 grams of Gatorade, and what is the mass of 10 milliliters of Sprite. So determine the mass of 10 milliliters of each of those beverages. Once you've found the mass of each of your beverages, you can see in this example here, the mass of Sprite was recorded to be 10.36 grams, the mass of orange juice was 10.37 grams, and the mass of Gatorade was 10.396 grams. You can determine the density. The formula for density is mass, which is grams, over volume, which is milliliters. In this case, we have 10.36 grams over 10 milliliters. So all we need to do is move the decimal point over 1. So the grams of Sprite, the density of Sprite, would be 1.036 grams per milliliter. You'll do the same thing for orange juice. So if we move the decimal place over 1, we get 1.037. And notice the units are here, grams per milliliter. And if we move the decimal place over for Gatorade, we get 1.096 grams per milliliter. So you'll record that in your data table. The next step is we're going to take a known density and graph this. We know this was data that was already determined for you. This is a sugar calculation that was already done for us. In this lab, we want to use the density that we calculated to find percent sugar. This data in this table right here was done by other researchers. It's a known reference chart that if repeated many times, you end up getting the same data. So what we need to do with this data is we want to graph it, and we want to graph percent sugar versus density. The percent sugar we can put on the x-axis. So this will be percent sugar. And you can see we need to go from 0 to 20. So each line can be 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Over on the side, we're going to have our density, and the density is going to be grams per milliliters. We're going to have to add another table so I can make it more clear for you. And we will put that, just overlap it right here. And